3 times 3 is 9. Therefore, the square root of 9 is 3. Okay, that's easy enough so far. 9 times 3 is 27. Therefore, the cube root of 27 is 3, because 3 times 3 times 3 equals 27. So if you have 3 cubes, how many different ways is it possible to arrange them so that they always share at least one edge with each other? Here's one way, 2 ways, 3 ways, 4, but wouldn't that be the same as this? Well, anyways, it turns out that there's 9. These are the 9 different ways that you can configure 3 cubes as long as they share an edge. When I realized that there was 9 possibilities, and each piece has 3, and 3 times 9 is 27, I realized that the cube root of 27 is 3. That means they should make a perfect cube. In theory, anyway. Well, I was really excited to make a prototype, so I stuck these together with staples real quick just to see if the thing worked. And it took me a while, but I did get it to fit. I really thought that I had something spectacular, and so I took it to a patent office, and it turns out that it already exists. This is called the Rubik's bricks, and I'm going to show you how you can make one if you want. This was my final version of the puzzle. Now, it should come as no surprise to you if you've never seen this puzzle before or never heard of it, because it was pretty much lost into obscurity because of this thing. I guess everybody probably just thought it was the same thing or another version of it. But that's exactly why I had never heard of it before. Now, the Rubik's version of the puzzle, the pieces are only red and gray, so there's only one way to solve it. So my version's a little more forgiving. But let me show you how it's constructed. This is what it looks like while it's under construction. When you look closer at the pieces, you can see that they're held together using pieces of 1/8 inch plexiglass. And it turned out to be pretty strong. I haven't broken one yet. The connections are made by making a saw cut at 45 degrees right down one of the edges. And then you can insert the plexiglass right in. When you're constructing it, you have to mind the spacing. It's really picky. The easiest way that I found to make this little saw cut is with a 45-degree angled jig like this for your table saw. You just run the piece right down the groove and it works great. It probably looks a lot more dangerous than it really is because such a small portion of the blade is sticking up. After you've made your cuts and you're ready to put your pieces together, you can just insert a little bit of epoxy or Gorilla Glue or something. Press them together and let them harden. When it comes time to assemble, a goofy looking jig like this can be really helpful. The pieces are incredibly picky when you're putting the puzzle together, so you want to be as accurate as possible. So correct spacing is mandatory. Once you've made all your connections, it's just a matter of using wood filler to patch the holes left by the plexiglass, and then sand, sand, sand. This piece is a pretty good example of one of the differences between this and the Rubik's version. I think the Rubik's version has this connection right here, so this combination isn't possible. I kind of like it like this. It leaves for more options. The dimensions of a single cube are 7/8 of an inch, so it's pretty small to work with. Making these little chamfers are really delicate. I have a delicate chamfering device video that shows one way that you could put this chamfer on a small object like this. A table saw or a router would just be too dangerous. This puzzle is deceptively difficult. but I think it's one of the greatest puzzles ever. I know I'm biased though, but I hope in some way this video helps to get this puzzle to reach a wider audience. So I hope you give it a try. Thanks a lot for watching.